Hey everyone, we are looking at combining independent random variables. So say we have this variable x where we have outcomes of 3, 5, 7, or 9 with equal probabilities of each. So this would be like reaching into a hat and pulling out a 3, 5, 7, or $9 prize. We're also going to have the random variable y, which has outcomes of 1 and 3 with equal probabilities on those. So it'd be like a different hat that you're getting $1 or $3. So starting out, what's your average value, the expected value? And that E of X actually means expected value. It's your mean. You can find this on page 367 of the book and on your formula sheet looking like this. Sigma, which means sum, of each number times the probability of that number. So for our expected value, we'll have E of X is 3 times a quarter plus 5 times a quarter, plus 7 times a quarter, plus 9 times a quarter. I know looking at this, you can be like, oh, I know the average value is 6 there. Yeah, it works if you use the formula too. I'm bringing this up just in case you have unequal probabilities. Okay, the variance is a measure of spread. So the variance is where you take each number, you subtract the mean from it and square it, multiply by the probability of that number, and then you sum them all. You do it for each of those numbers and add them up. Standard deviation, remember, is the square root of variance. So you just take the square root of your variance. And those can be found on 369. And they're just measures of spread. So you might want to write this down. You could hit pause, you know. Okay, so for our variance we have, take our first number, 3, so 3 minus 6, square it times a quarter, plus 5 times 6, you square it times a quarter, plus 7 minus 6 squared times a quarter, plus 9 minus 6 squared times a quarter, and that adds up to 5. I'm sure you'll take my word for it. You can crack out your calculator if you'd like. And then finally, our standard deviation of x is going to be the square root of 5, which is 2.236. It'd help if I could write that. Erasable pens for the win. Okay, so we'll do the same for y. It's pretty quick. So our average value, of course, is going to be, the expected value rather, is going to be 2, because our expected value of y is 1 times a half plus 3 times a half. Our variance will be 1 minus 2 squared times a half plus 3 minus 2 squared times a half, which is 1. And then our standard deviation of y is the square root of 1, so 1. I know I went through that super fast, but it's the same exact process. Okay, that's the boring bit. Now things get more interesting when we have to combine them. So if we have x plus y. So that means that it would be like reaching into that first hat and pulling out the 3, 5, 7, or $9, and then reaching into the second hat and getting $1 or $3. So worst case, you'd have $4. Best case, you'd have 12. And what's the probability and what values can we have? So the way to do this will be to make a tree. So we have our first part of our tree has 4 branches with the 3, 5, 7, and 9. And we have probability as of 0.25 on each of those. And then coming off of each of those, we have a 1 or a 3. And so you'll have 0.5 out probabilities on each of those. And if we multiply all the way through each of those branches, obviously we're getting the exact same number for each, that 0.25 times 0.5, 0.125, or an eighth. We have 8 outcomes here. So you can get that $4. You can get 3 and 3, you get 6, or 5 and 1, you get 6 again. 8, 8, 10, 10, and 12. So the outcomes, the values that z can take, this is called your sample space, little vocab alert. It's good to know our vocab, and that's something you do need to know. So our sample space would be the 4, 6, 8, 10, and 12. But these aren't equal outcomes for each, are they? Because the 4 and the 12 only happen 1/8 of the time. And then the 6, 8, and 10s happen 2/8 or a fourth of the time. So now finding our expected values of these, we can probably figure out by the symmetry of this that the expected value is 8. But again, we want to show proper work. So I'll switch back to the blue since it's darker. So our expected value of z, that x plus y, is going to be 4 times an eighth plus 6 times a fourth plus 8 times a fourth plus 10 times a fourth plus 12 times an eighth, which gives us an expected value of 8. Our original expected values were 6 and 2. We added them together and we have 8. Coincidence? I don't think so. In fact, we could even make a rule of this. The expected value, if you have 2 independent random variables, because x and y are independent of each other, that's why we call them independent random variables, and you're randomly getting any of those outcomes. So that's your expected value of x plus your expected value of y. Let's see what happens for our variance. So for our variance of z, we have each of our outcomes minus the mean, so 4 minus 8 squared times an eighth plus 6 minus 8 squared times a fourth plus 8 minus 8 squared times a fourth plus 10 minus 8 squared times a fourth plus 12 minus 8 squared times an eighth, and that all adds up to 6. Oh, but wait a minute. We had a variance of 5 before, and then we had a variance of 1. Now when we added things together, we have a variance of 6. Also not a coincidence. Our variances, when we're adding these guys together, is simply the sum of the variances. But then our standard deviation of z, we know is the square root of the variance, so the square root of 6. And the square root of 6 is about 2.45. And 2.45 is not the sum of our original 2 standard deviations. So for the standard deviation, it's not the standard deviation of x plus the standard deviation of y. It's just the square root of our variances summed. In fact, what we really have here, looks like this would be the standard deviation. If I squared both sides of this, I would have the standard deviation squared, right? And the variance is the squares of the standard deviations of x. So really what we have here, the standard deviation of x plus y, I'm going to write this and then I'll add another pen color in a sec, so give me a moment. The standard deviation of x plus y squared is equal to the standard deviation of x squared plus the standard deviation of y squared. Does that look familiar? It should. That's the Pythagorean theorem. Crazy, isn't it? Okay. Continuing on. By the way, on all of this, I'm working on the assumption that you're hitting pause to write things as needed because I'm going pretty quick. Okay. We now have a new prize. Instead of getting to add our 2, we're going to subtract them. So you pull out your 3, 5, 7, or 9. And then after that, you have to subtract off $1 or $3. Bummer. I'm not putting my probabilities in just for the sake of space. I'll just add that little note. All probability is 0.25. P equals 0.5 for all those. So our outcomes then, 3 minus 1 is 2. Worst case, you get nothing. You can get 4, 2, 6, 4, 8, or 4. So our sample space on this is 0, 2, 4, 6, and 8. our probabilities on those, the 0 happens 1/8 of the time, as does the 8, and the rest are 1/4 of the time. Okay, let's speed this up a little bit. So we can do this on our calculator. So I went into Stat and Edit, and notice, ignore these two guys, they're coming back later. I have the 0 through 0, 2, 4, 6, 8 in list 1. I have my probabilities in list 2. I can do a one var stats, so stat calc 1 var stats, and I can put list 1 is my list, and then frequency list is list 2. You can do this with, like, if you could have actual frequencies, like how often each of those things happened, or you can put probabilities into that list too. And then I hit calculate, and it gives me my mean of 4 and a standard deviation of 2.449. It doesn't give me my variance, but I can figure that out by squaring my standard deviation and just kind of figuring it out from the rounding. So looking at this, the thing you need to write, though, even if you're using 1 var stats, you still, this is a College Board standard. The way we would write this, you would usually write out like the first thing, so the 0 times 1/8. You would write the second one, so plus 2 times 1/4. And then you can do a plus dot, 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 plus the very last thing, the 8 times 1/8, and get your outcome, which was 4, remember, from our calculator. So that's what you need to write. So if you use that, using the 1 var stats, you still need to write stuff down. You can't just give an answer. That is just one of those things. We know we never have those naked numbers. Our variance then is going to be that, again, I'm going to just write the first part. So 0 minus 4 squared times 1/8 plus 2 minus 4 squared times 1/4 plus dot, 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 plus 8 minus 4 squared times 1/8. And that was that 2.449. So 2.449, I know it went further than that. I'm going to square it. It gives me that 5.997. I can go, oh, that was really 6. So we have a variance of 6. And then our standard deviation of W is the square root of 6, which is that, I just forgot the number we had. Good job, me. 2.449. Or 2.45. So notice that these numbers, the variances of W's, even though we subtracted, the variances and the standard deviations actually matched what we had when we added. And that makes good sense, because 4 to 12 with these probabilities is basically just a shifted version of this 0 to 8. Like, this is taking that initial set and just subtracting everything 4 and just moving the thing down 4 units. It's exactly as spread out as it had been before. So our expected value of x minus y is the expected value of x minus the expected value of y, because originally we had, a reminder, 6 and 2. So we just subtract those. But then our variance of x minus y, and this is a little counterintuitive, but it makes sense when you see it worked out, is that it's still just the variance of x plus the variance of y. And then our standard deviation of x minus y is still just your square root. So variance of x plus your variance of y square rooted. Okay, whew, flying through this. Okay, now, let's say we have a new random variable called a, where it's equal to 2 times y. So, which that means if you're just doubling your values in y. So remember, we had 1 and 3 with equal probabilities. So 2y, we would have 2 and 6. And our mean on that, mean of 2y is going to be 2 times a half plus 6 times a half, because those were equal probabilities of happening. So 1 plus 3 is 4. Our variance of that 2y is, sorry, I have this written down. I had to get to the right spot. 2 minus 4 squared times a half plus 6 minus 4 squared times a half, which is 4. And remember, our previous variance was 1 when it was just y. And our previous mean was 2. So we've doubled our mean, but we've quadrupled our variance. That's going to come back in a second. And then our standard deviation of 2y is going to be root 4, or 2. Okay, so for b, we have y plus y. I'm just going to use those rules we just figured out. So the expected value of y plus y is the expected value of y plus the expected value of y, which is 4. So it seems like these are the same so far. But then our variance of y plus y is going to be the variance of y plus the variance of y, which that variance, remember, had been 1. So that's 2. Because remember, if you're doing 1, 3, 1, 3, that would be looking at this, right? So our outcomes are 2, 4, 4, and 6 versus just outcomes of 2 and 6. So definitely not the same things. So they're not equivalent at all. And since you have numbers between 2 and 4, this is not considered as spread out as just 2 and 6 alone. So it has a smaller variance and therefore a smaller standard deviation. Okay, if you're watching this video, your handout does not look like mine on this spot. I added this in because it's a helpful thing. Okay, say we take the variable x, which was that 3, 5, 7, or 9, and we're going to do 7x. So I'm actually going to just do this on the calculator for the sake of time. So in my calculator, in list 4, I have 3, 5, 7, and 9 all multiplied by 7, still the same probabilities. And then I'm going to do my stat calc 1 var stats. Sorry, my light is making a glare on there. List 4, list 5. So now I have a mean of 42. Reminder, before we had a mean of 6. So the expected value of 7x is 42, which is 7 times the expected value of x, that 6 we had before. Our standard deviation is 15.6524. I'll come back to the variance. Our original standard deviation was the square root of 2, or sorry, the square root of 5, or 2.236. If we take that 15.64652, which I've actually stored it, I think, as a, yep, I have it here. So if the original one was the square root of 5, so this is, notice we're 7 times bigger. 7 times our original standard deviation of the square root of 5 is the same as our standard deviation. So this is 7 times the original standard deviation of x, which implies that our variance being this squared, the variance of 7x, which is the standard deviation squared, here's my standard deviation, if I square that, 245, 245 divided by the original variance of 5 is 49. So our variance of at 7x is 245, which is 49 times the variance of x, or 7 squared. So to summarize all this, And your handout does not have the stuff I have on the bottom. Please add that in. Pause the video and write all of these guys down because these are all of our formulas that we have. And I hope this helps you to understand the rules for combining independent random variables. Just hit pause, write this down, and you should be good to go.